In the previous lecture, we have read about the definition of quantum and all the quantum numbers. In this lecture, we will know in detail about the spin quantum number. Which quantum number? Spin quantum number. Spin quantum number. Spin quantum number. Spin quantum number. It is denoted by small letter s. It is denoted by s. Spin quantum number indicates the spin of the electron. Spin quantum number. Spin quantum number. Spin quantum number indicates the spin of the electron. Indicates the spin of the electron. It is observed that electron moves around the nucleus in orbit and at the same time spins around its own axis. It is observed that the electron moves It is observed that the electron moves around the nucleus, around the nucleus, in orbits, and at the same time, rotates. That means rotates. It's around its own axis. The spin, that means any electron move around the nucleus, and moves around its own axis. The spin of the electron produces a small magnetic field. The spin of the electron produces small magnetic fields. Produces small magnetic field, due to which electron behaves as tiny magnet. Due to which electron behaves as a tiny magnet. Electron behaves as a tiny magnet. Since electron can spin either clockwise or anti-clockwise. Electron spins clockwise or anti-clockwise. As spin equal to plus 1/2, that means clockwise. If spin moves around its own axis anti-clockwise, then s equal to -1/2. This is the anti-clockwise. Therefore, spin quantum has two values. Since electron can spin either clockwise clockwise or anti-clockwise or anti-clockwise. Therefore, spin quantum has two values. Spin quantum has two values. Plus 1/2 or minus 1/2. Its value does not depend upon the values of other three quantum numbers. Its value does not depend depends upon the value of other three quantum numbers. Upon the value of three quantum numbers. The two orientation as expressed by arrows pointing. The two orientation are expressed by the two orientation are expressed by the two orientation are expressed by arrows pointing up. Arrows pointing up. That means plus 1/2 and down. That means minus 1/2. The plus or minus sign depend upon the clockwise or anti-clockwise direction of the spin. Hence, the four quantum number specify the position of an electron in an atom by describing its main energy level, orbit number n, orbital L, orientation of the orbital m, and direction of electron spin s. Principal quantum number n describes main energy level. Orbit number. That means orbit number. And orbital L and azimuthal quantum number L describe the orbital sub energy level. It's known as subsidiary orbital. And M, that means magnetic quantum number, describe the orientation of the orbital. Describe the orientation of the orbital. Orientation of the orbital. And the fourth number, spin quantum number, is describe the direction of electron spin. Direction of electron spin. Evolution of quantum number for an electron. The state of an electron in an atom can be described by set of four quantum numbers. The quantum numbers specify the location and energy of an electron. Each quantum number is associated with a particular characteristics of the electron which they describe. In order to evaluate the 4 quantum number of an electron, first of all, we write down the electronic configuration of the atom on the basis of increasing energy of Bohr principle. Is that the electron configuration of Na is given as below. Na, that means sodium. Na11 is that 1s square, 2s2, 2p6, 3s1. Suppose we want to find out the 4 quantum numbers. Suppose we want to find the 4 quantum numbers of last electron present in sodium. Since last electron of sodium is present in 3s orbital, 3s orbital, 3s orbital, 3s orbital, 3s orbital, orbital, 3s orbital. Since the last electron of sodium is present in 3s orbital, last electron present in 3rd orbit. Hence, its principal quantum number n equal to 3. Principal quantum number n equal to 3. As last electron is in s orbital, so azimuthal quantum number L equal to 0. L equal to 0. L equal to 0 because last electron is in s orbital. Last electron is in s orbital, so azimuthal quantum number L equal to 0. Since last electron E is in s orbital, last electron E is in s orbital, so hence m equal to 0. Now we can determine spin quantum. In each box of an orbital, maximum 2 electrons exist. For first electron, s will be plus 1 by 2, and for second, s will be minus 1 by 2. Hence, last electron of sodium atom is in s orbital, which is first in 3s orbital. So the value of spin quantum number will be s equal to plus 1 by 2 because only one electron in the last orbital present. The 4 quantum number for last electron sodium are given as follow: n equal to 3, principal quantum number 3, azimuthal quantum number 0, magnetic quantum number 0, spin quantum number plus 1 by 2. Plus 1 by 2. As an example, an electron, example, an electron in an atom has n equal to 2, L equal to 1 and m equal to 0. Name the orbital. Name the orbital. Solution. When L equal to 1, the orbital is P. Orbital is P orbital. And since m equal to 0, hence it is Py. The orbital is 2py. The orbital is 2py. Identify orbital with the help of following NL values. If n equal to 2 and L equal to 0, then orbital equal to 2s orbital. 2s orbital because n equal to 2 and for s L equal to 0. If If n equal to 4, comma l equal to 2, then orbital. Orbital. Which orbital? That means 4. 4, l equal to 2. That means d orbital. That means d orbital. S, p, d. If n equal to 3, comma l equal to 1, comma l equal to 1, then orbital. 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 Orbital equal to, for n equal to 3, 3. L equal to 1. That means for 1, p orbital, 3p. 3p. And so on. Example. For n equal to, find out the maximum number of electrons present in an orbit. Next example. Next example. For n equal to 2 or for n equal to 3, find out the maximum number of electrons present in orbit. Maximum number of electron present in an orbit equal to 2n square. That means 2 multiply 3 square equal to 3 3 is 9 2 is 18 electron. How many electron? 18 electron. Find out the total values of L, M for principal quantum number solution, and we will find out the total numbers of quantum numbers in next example. Okay? In next example, if a principal quantum number n, principal quantum number n equal to 1, n equal to 1, subsidiary quantum number n, subsidiary quantum number L, that means azimuthal quantum number equal to 0, and magnetic quantum number is magnetic quantum number magnetic quantum number n equal to 0, because L equal to 0. Its value depend upon the L and its value depend upon n. The spin quantum number S equal to plus 1 by 2 and minus 1 by 2, because this is the 2s. This is the 2s, total electron. For principal quantum number n equal to 2, then the value L equal to 0, 1, then the magnetic quantum number for M for L equal to 0 is 0, and magnetic quantum number for L equal to 1. L equal to minus 1, 0, plus 1, and spin quantum number S. For n equal to 0, plus 1 by 2, minus 1 by 2, plus 1 by 2, minus 1 by 2. My spin quantum number for n equal to m equal to minus 1, m equal to minus 1, plus 1 by 2, minus 1 by 2, plus 1 by 2, minus 1 by 2. Spin quantum number for m equal to plus 1. That means plus 1 by 2, minus 1 by 2, plus 1 by 2, minus 1 by 2. For n equal to 2, total n equal to 2, total number of electron, total number of electron equal to 2 plus 2 plus 2, 2 plus 2 plus 2, and 2 and 2, 8 electron, 8 electron, 8 electron. How many electrons? 8 electrons. Sorry, 2, 2, 2, 6 electron, 6 electron, 6 electron, 6 electron. 6 electron and 2 to 4 and 2 electron for this, and 2 electron for this s equal to 0, s equal to 0, plus 1 by 2, minus 1 by 2, minus, and for this s equal to, for s equal to, for s equal to s equal to 0, for sorry, m equal to 0, the value is plus 1 by 2, minus 1 by 2, 2 to 4 to 8 electron. Total number of electron, equal to 8. Spin quantum number, and spin quantum number for n equal to 4. For n equal to 4, for n equal to 4, for n equal to 4, principal quantum number, principal quantum number, principal quantum number 4, and next is azimuthal quantum number. Next is azimuthal quantum number. Principal quantum number is 4. Next is azimuthal quantum number. Azimuthal quantum number. Azimuthal quantum number L. Azimuthal quantum number L. 0, 1, 0, 1, 0, 1, 2, and 3. And next is magnetic quantum number. Which quantum number? Magnetic quantum number. Magnetic quantum number. Magnetic quantum number. For 0, m equal to 0, 1 equal to minus 1, 0, plus 1. For azimuthal quantum number 2, magnetic quantum number equal to minus 2, minus 1, 0, plus 1, plus 2. And magnetic quantum number for 3, azimuthal quantum number, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, plus 3, plus 3. Then spin quantum number S. Spin quantum number S. Spin quantum number S. Plus 1 by 2, minus 1 by 2. Plus 1 by 2, minus 1 by 2. Plus 1 by 2, minus 1 by 2. And plus 1 by 2, minus 1 by 2. This is the plus 1 by 2, minus 1 by 2. This is the plus 1 by 2, minus 1 by 2. This is the plus 1 by 2, plus 1 by 2, minus 1 by 2. And so on. And so on. Every plus 1 by 2, minus 1 by 2, plus 1 by 2, minus 1 by 2, plus 1 by 2, minus 1 by 2. Then the value is 2s, 2p, 2s, 6p, 2s, 6p, 10d, and 14f, 14f, 14f. Because and magnetic quantum number 0, 0 azimuthal quantum number 0. So principal quantum number s orbital, and principal azimuthal quantum number 1 for p orbital, p s orbital, p orbital azimuthal quantum number 2, d orbital azimuthal quantum number 3, f orbital. In f orbital, total number of electron 2 to 4 to 6 to 8 to 10 to 12 to 14. In f orbital, total number of electron present 14. In d orbital, total number of electron present 10. And p orbital, total number of electron present 6. And s orbital, total number of electron present 2. It's okay. Thanking you.